All right, we're going to continue our study of polynomials. The next set of presentations, we're going to talk about factoring. And for many students, factoring is another F word in mathematics. So if you struggle with these, I encourage you to find other resources online in order to understand it a little bit better. I will be uploading my 114 material, so I encourage you to watch those as well if you need more examples. All right. In this section, we're just going to talk about greatest common factor and factor by grouping. So let's go ahead and talk about greatest factor in terms of polynomials. Greatest common factor, this is an expression of highest degree that divides each term of a polynomial or list of expressions. When determining the GCF, you want to look at the numbers in each variable separately. And for each variable, we will keep the smallest exponent. We take the smallest as that is the most that they all have in common. So the first thing we're going to talk about is factoring out the GCF. This is the opposite of distributing. So the first thing we want to do is determine the GCF for all terms in the polynomial. We're going to write the GCF outside a set of parentheses and divide each term by the GCF and write the result inside the parentheses. Check that there are no other common factors that can be factored out, and check your answer using distribution. All right, so let's see how this works. Let's start with example A. Example A, I want to look at my two terms here, and I want to determine the GCF. So what is the largest number that divides into 6 and 18? The answer is 6. Do we have any y's that we can factor out? Do they have any y's in common? And the answer is no. This term has no y's, so there will be no y's in our GCF. So my GCF is just going to be 6. I'm going to write it outside a set of parentheses. And now I want to divide each term by 6. So 6y squared, if I divide by 6, I am left with y squared. Minus 18 divided by 6 is 3. And you're done. If you distribute, you will find that you get the original problem back, and that's the goal. All right, let's look at example B. So let's go ahead and start with the numbers. 15, 12, 27, and 3. My greatest common factor is 3. All of these numbers are divisible by 3, and nothing larger will divide into all of them. For my x's, what is the most that they have in common? Well, as I said on the last slide, we always pick the smallest exponent. If you have 5 x's, do you have at least 2? Yes. Same thing for x to the 4th, x cubed, and x squared. So we always go with our smallest exponent. So my GCF is 3x squared. All right, if we go ahead and divide each term by 3x squared, 15 divided by 3 is 5. X to the 5th divided by x squared. If we divide, remember we subtract the exponents. We are left with x cubed minus 12 divided by 3 is 4. X to the 4th, if you take out 2, you will be left with 2. 27 divided by 3 is 9. X cubed, if you take away x squared, you are left with just 1x. Minus 3x squared divided by itself is 1. Note if the whole term factors out, you are left with 1 because we are dividing. And we're done. All right, last one. Let's see what we can do here. Let's start with our numbers. 8, 4, and 10 are all divisible by 2. My p's. We have 6, 5, and 4. Remember, we want to go with the smallest one because that is how many they have in common. For my q's, I have 2, 3, and 4. I want to go with the smallest one, so we're going to factor out a q squared. All right, if we divide each term by our greatest common factor, we get 8 divided by 2 is 4. P to the 6, if I factor out 4, I am left with 2. And we factored out all of the q squared, so we don't have any q squareds left in this term. Minus 4 divided by 2 is 2. P to the 5th, if I factor out 4, I am left with 1. Q cubed, if I factor out 2, I am left with 1. And so we have minus 2pq. Plus, last term, 10 divided by 2 is 5. P to the 4th, we factored out the whole p to the 4th, so we don't have any p's left. And q to the 4th, if I factor out 2 of them, I am left with 2. All right, let's do a couple more examples. Let's come up to example D. Now for these next two, we want to practice factoring out a negative. And so it's similar to multiplying through a negative. You just need to make sure that you factor out the whole thing. Now for these, technically you don't have to, but we're going to see later on in other presentations that sometimes we may want to factor out a negative, especially when our leading term is negative. So let's see what we can do. My GCF is 4 for 4x and 24. We don't have any x's in it. And as I said, I want to factor out a negative as well. So the first term, if we divide by negative 4, I am left with just an x. Negative 24 divided by negative 4 is plus 6. All right, let's look at example E. The first thing I want to do is I see a typo on here. So let's change this second 3 to a 2. Otherwise, we can combine the like terms. All right, so let's go ahead and see what we can do here. My greatest common factor for 2, 6, and 2 is 2. Again, I want to factor out a negative. If we have x cubed, x squared, and x, what is the most they have in common? They all have at least one x. So now if we go ahead and divide by negative 2x, we get, for the first term, x squared. My negative 2 goes away. Out of my 3, I pull out 1. That leaves me with 2. 6 divided by negative 2 is negative 3. X squared, if I factor out 1, I am left with 1. And negative 2x divided by negative 2x divided by itself leaves me plus 1. Okay, so those are some examples of factoring out a negative. Last thing we want to do is factor out a binomial. So notice that it said expression of highest degree. And so not only can you factor out numbers, not only can you factor out variables, you can also factor out an expression, for instance, a binomial. So what we want to do here is I want to pretend this is one thing and this is a second thing. What do they have in common? They have the a minus b. So I'm going to take my a minus b and I'm going to factor it out. I'm going to write it in front of a set of parentheses. So in my first thing, if I get rid of a minus b, what am I left with? I am left with an x. In my second thing, if I get rid of the a minus b, what am I left with? I am left with plus y. And this is factored. And this is something we're going to use in the next slide when we talk about factor by grouping. This is actually an intermediary step. All right, so now let's go ahead and talk about factor by grouping. The first thing to note when using factor by grouping is you must have 4 terms. What we're going to do is we're going to factor out the GCF from the first 2 terms. We're going to factor out the GCF from the last 2 terms. And then from there, we should have a common binomial that we can factor out. So let's go ahead and see what this looks like. If we look at example A, we're going to start with our first 2 terms. What do they have in common? They have an x squared. I'm going to factor it out. What am I left with? X cubed. If you factor out an x squared, you are left with just 1x. 3x squared. If we get rid of the x squared, we are just left with 3. All right, for the second set, I'm going to bring down my plus sign. For the last 2 terms, I can factor out a 4. So I'm going to bring a 4 out. Inside, 4x divided by 4 is x. 12 divided by 4 is 3. Now we're back to that last example that we looked at. So again, I want to treat this as one thing, and I want to treat this as a second thing. What do they have in common? They have x plus 3. All right, first thing, if I get rid of x plus 3, what am I left with? I am left with x squared. Second thing, if I get rid of x plus 3, what am I left with? I am left with plus 4. And now we factored something using factor by grouping. Let's try one more. All right, so let's start with the first set, first pair. What can we factor out? We can factor out a 4. T cubed and t squared. I'm going to take my smallest exponent, so I'm going to take my t squared. And then now I want to divide each term by this. 4 divided by 4, I get 1. T cubed, if I factor out t squared, I am left with 1t. 20 divided by 4 is 5. And we factored out the t squared, so we don't have any more t's in that term. All right, second set, this is where we have to bring in that idea of factoring out a negative. So here I want to factor out a minus 3. All right, first term, if I divide by negative 3, I am just left with t. Second term, if I divide negative 15 by negative 3, I am left with plus 5. Now, if you get that your binomials are not the same, then you do want to check that you factored out your negative. That's always going to be the first thing that might be an issue. All right, so now we can go ahead and factor out the common binomial. So each thing has a t plus 5, so I'm going to write that in front. And the first thing, if we get rid of t plus 5, I am left with 4t squared. Second thing, if I get rid of the t plus 5, I am left with minus 3. All right, so that takes care of factor by grouping. All right, the last thing we want to talk about is solving polynomial equations. So the first thing we want to do is we want to set the equation equal to 0. If we need to move all terms to one side of the equation. From there, we want to factor, and we're going to set each factor equal to 0 and solve. For polynomial equations, there is a good chance you will have more than one solution. All right, let's try some examples. Example A, this is actually already set equal to 0, and it is already factored. So this is kind of our base case. So this is just going to be set each factor, each set of parentheses, equal to 0. We have two little equations. These are linear now, and so now we use our rules for solving linear equations. So x minus 3 equals 0. To get x by itself, I want to add 3 to both sides. We get x equals 3, or for the second equation, to get x by itself, I want to subtract 2 from both sides. We get x equals negative 2. Now on your homework, you might see the squiggly braces. You can write your answer 3 comma negative 2 inside squiggly braces. It has to be squiggly braces. If you use parentheses or square brackets, then that means something else. The squiggly braces just mean x equals 3 or negative 2. All right, one more. So this one, the first thing I note is this is not set equal to 0. So the first thing I need to do is I need to move everything to one side of the equation. I'm going to subtract 30x. From there, we can factor out a greatest common factor. Both of our numbers are divisible by 6, and both terms have an x. So if we factor out 6x in the first term, 6 divided by 6 is 1. X squared, if I pull out 1x, I have 1 left over. Minus 30 divided by 6 is 5. And we already factored out the x. So we have two factors equal to 0. The first one is my greatest common factor. We get 6x equals 0, or x minus 5 equals 0. So let's solve each one of these little equations. The first one we can divide by 6. We get x equals 0. Or, second equation, I can add 5 to both sides. And we get x equals 5. If we want to use set notation, we can do this. All right, that takes care of our introduction to factoring. The next section we will look at factoring x squared plus bx plus c. We're going to start factoring trinomials. All right, so go ahead, take a break, and I will see you guys again shortly.